very shortly. Apart from that, let's discuss today's agenda. Our agenda today is to have a firm grasp over STL. Now, this is standard template library in C++. It is a very useful tool. You can shorten the time it takes you to solve some problems very quickly, so you don't have to implement everything and anything. Regarding Java, you can also see there is something known as Java collections. It is very similar to this thing. So you can independently study that, but here we will be teaching STL. Also, we will try to solve a few questions if time permits, so we can use the tips and tricks that we are learning. Apart from that, there is an ideal code editor setup for solving, and I will be sending a video. It's a video by Striver, so you can see that and set up your code space. I'll show you my code space, how that works. So just let me get over real quick. So I'll change my window. Just give me a second. So this right here is my code space. As you can see, here is my code. Here is the input. Here is the output. I'll send you a video. So right now you do not have to worry about this. So let's start with the session. Firstly, a very famous quote that goes in memes. And now for my next trick, I'm going to teach you in 2 months, but took me over 2 years to ChatGPT. Again, why is it very important to study from someone experienced rather than banging your head? Is that you can save a lot of time. As you can see, you have 2 months of summer vacations. So having somebody teach you everything that they've learned in a very short span is a very good thing, I say. Of course, you will be solving the problems yourself as well. It's not that we will be entirely spoon feeding you. Apart from that, how to make the most out of these sessions? Of course, ask doubts. That's a very valid point. Feedback is also very important. If you feel at any point you feel that it's not up to the mark, you just tell us after the session. And of course, you have to ask the doubts at the end of each question's discussion so that you don't disturb me or anybody else. And solve beforehand. Today we have not given you the questions. Now once we end the revision or introductory sections, we will be giving you questions. So you can solve that. And if you're not able to solve, you can still come over this session. And compete. We will be revealing the CC scoreboard very soon. So you can know how to compete on that. There will be monthly winners, weekly winners, and of course daily winners as well. So there will be a standing or ranking, you can say. And again, be patient. So it is possible that you might have solved the question and you may wonder, why must I join the session? It's just sometimes to discover a better approach from somebody else, or maybe you have a better approach that you would like us to discuss with everybody else. So that's one more thing. And one unsaid rule of a meeting is maintain the decorum. Even though you have the access to chat and the reactions, it is always advisable to be very conscious of what you're saying. My voice is breaking. Can I have a show of hands if you can listen me properly, or is it just somebody else having a problem? So you can listen me properly, right? Okay, I think Saksham, you might have some problem on your end. Still, if it persists, just text me again. So what is STL anyway? So STL in C++. Okay. STL in C++. So STL in C++ is a powerful set of C++ template classes that provides general purpose, very usable data structures and algorithms, yada yada yada. You get the idea. STL is basically a sort of C++ template classes that gives you the ability to have many data structures at your hand. So you don't have to implement a lot of data structures like you might have implemented in C. So STL gives you stuff like containers. Containers are your data structures. These include vectors, lists, map, sets, etc. Algorithms, sort, find, binary search, and many more. And iterators. Now, iterators is very important for a little bit advanced data structures. So we will be teaching you that as well. But before that, what is a vector? Now, if you have watched Despicable Me, I am not talking about this dude here. Why use a raw array when you can use a vector? So it's anything but this dude. So a vector in C++ is a dynamic array from the STL standard template library that can grow or shrink in size at runtime. And that is a very important difference between a vector and an array. We'll be discussing that again. It provides convenient functions like pushback and supports random access like arrays. So what is random access? We'll also discuss that. It's somewhere below. So what it says is a vector allows you to grow or shrink your data structure that is similar to an array. So So in case you want to have a lot of elements and you do not know initially how many elements you want, so you can do that. Also, you can reduce the size. So apart from arrays, which actually we cannot reduce size of, in C you used to do dynamic memory allocation using malloc calloc, but here you can simply just use vector. So let's discuss some differences between vector and array. So here's a screenshot from ChatGPT because I was too lazy to type and making all this. So size. Now array has a fixed size at compile time. Compile time is when you've written your entire code, you hit run and it compiles. And you see vector has a dynamic size, so it can grow or shrink. And there's one more column you might see. So do we care yet? Now this column is important because there are a lot of differences that you do not need to know at this point. You need to know them when you are working with a little advanced data structures. So as of now, I don't think you need really some of these differences. So talking about the size, yes, we do care about it. Uh, and let's talk about memory allocation. Array has stack-based memory allocation, while vector has a heap-based. Do we care that? No, we don't. Syntax. So this is how you create an array, but this is how you create a vector. Do not worry, we will be discussing it down there. So it's just a very subtle difference. You can see it's got the same thing as int because that is the data type. And again, the name here it's array, here it's v, but you see angular braces, also known as angular operator. So here it is. Yes, we do care about it. Then resizing. Array, as we mentioned, is not possible to resize. Vector, however, can be resized using pushback or resize. We will be discussing that. But as at this point, do we really care? No, because many problems that you will be dealing with do not really require you to resize your array, resize your vector. It's just you use it for simplicity. Built-in functions, yes, this is very important because array really does not have many built-in functions. You do have that size thing, but here there are a lot of built-in functions because that is the main crux of using SCL. It has a lot of algorithms, it has a lot of iterators, and so yes, we do care about it. Safety, no bounce checking, has dot add with bounce checking. Again, we don't really care. Header required, as you might have done in C, you use that, if I remember correctly, you use header at top of your files. So similarly, you need to include vector. So without that, you cannot really use that. Use case, when size is known and fixed, that is for array. And when you know that your size might change, so again, not shit Sherlock, we know that's why we're using vector. So why use vectors? Any idea? See, all the above reasons and a remote. So the thing is, we use vectors because of all these reasons. Vectors make it very easy for you. In competitive programming, we use vectors because sometimes you have to resize the array and you have to check a lot of things. On lead code, if you go to any question that has a CPP template, you will see that they use vectors. None of them use arrays. Vectors are really easy to use. And so again, there's a little name for you to remember that vector is a very strong data type, data structure. Now creating a vector. Let's start. So how do you create a vector? So this here just creates a vector. It does not tell the compiler how much memory you want. It does not tell which elements the vector has. It just says vector, begin, data type, and name of the vector. Of course, you do not need to put data types in double quotes or name of the vector. It's just here for you to remember. So here you see that vector. So int is the data type, integers, nums, letters, and for string you can use words, and of course bool. Bool is a boolean. It's either true or false. You can represent it also as 1 or 0. So to be or not to be. That is for bool. Because the answer is just be, true, or not to be, false. Now, how is this creation of a vector different from the creation of an array? You see here, we create a vector of int, let's name it vnums, and we create an array known as array nums. Now, this array we define the size to be 10. But here you can see we have not defined anything regarding the size of the vector, like how many elements are there in the vector. We say that no memory allocated in the vector, but for array you have allocated 10 blocks of integers. Now we are not saying it is occupying 10 bytes, 10 bits, 10 kbs or 10 megabytes. What we are saying is one integer, let's say, occupies 1 unit. So this vector, this array occupies 10 units. But this vector, it has not occupied anything. So we say array of num 0 0 to 5. So that is correct. Why is it this correct? Because we have actually allocated some memory for this array. However, for the vector, we have not allocated any memory, even 0, even that means first element, 0th index, we have not allocated any memory. So it says wrong because no memory. No memory, so you can't push elements into the vector. Hence, you get an error when you try to access this thing. vnums. It says finished. That's my compiler doing its thing. The main thing you focus at is this error. It does not simply say that you have not allocated memory. It gives you very vague errors, which is very standard when you look at it. But right now, it will look to you as very vague. So what you're doing is you're trying to access something that's not allocated for you. So the vector has not allocated any memory, but you're trying to access the first element or the element at zeroth index. You're trying to put some element into it, for example, 5 here. So we need to also allocate some memory to the vector. We have defined the vector. We said that this is a vector. The compiler knows that there is a vector known as nums, letters, words, and this of this type. But it says that it's empty. It has no memory. We cannot push anything into it. So what do we do next? Also, is something handy to remember. In C++, we don't say a lot of things. We just tell you this whole error. So that's a fun little way to remember. Now, what do we do? How do we actually push elements into the vector? Now, you might have seen the array. Once you define an array, you put elements into it in this form. The same goes for a vector. You could do this. You could say vector in terms is, and that means this vector right now holds 69420. But does that mean this vector will only hold this? Can we not push any more elements into this? No. When you do this with an array, for example, this will be just this. So there are no more elements that you can push into it, and you cannot really reduce the size of the vector. But once you have a vector, you can actually push more elements into this. For example, if I want to push, let's say 314, so it could be 69420 314. It could be 8 values. Or if I want to remove these values, I just want the first three, so 694, I could just have that. Or you could do one more thing is you define a vector in nums, but you also tell the compiler that please allocate n blocks or n size of ints to it. That means all the elements are zero because by default this is zero. Now if you say vector in terms n comma 1, that becomes all the elements are 1. Do not do the mistake of putting 1 before and n after, because that would mean, okay, the compiler says that I need to have 1, if you put 1 in front, that I need to have 1 block and each block has a value of n. No, it goes firstly how many blocks we want to put, and after that, what does each block need to have? By default, it's 0. If you put something else, it becomes that. One more thing that you can do is, so you can have input from the user. How you do that? So it says, but I want to insert elements at runtime. What do you do? So what you do is, first you have n5. We declare the vector here. Of course, we have not allocated any memory. Since we have not allocated any memory, we cannot really push elements into the vector. Once you do declare some memory for the vector, by default it's 0. You see, by default it's 0 values. So we override those 0 values and we say seen nums of I. That means seen, as you know, in C++ means you take input from the user. So it puts, so let's say index 0, so nums of 0. As we can see, we can access that because we have actually allocated some memory. We first need to allocate the required memory to a vector. Once you've done that, you have access to all those elements. So first you've given it 5 blocks, and then you can put some elements into those 5 blocks. After that, let's see here. You could also do one more thing, and that is you could, instead of doing this seen nums of I thing, you could still not allocate any memory to the vector and still push elements into it. How is that? Firstly, we input n. Now, n is the number of elements we need to put into the vector. Then we input those elements. How does that go by? So what you do is you say in temp, seen temp. Now you have temporary variable that holds some current value. That value you can push into the vector and says nums.pushback temp. Remember above we said we can use pushback to actually resize the vector. This is how it does. So each time you push back some value into the vector, its size increases by 1. So by default here, its size is 0. You take some temp variable and you put some value in it, and then you push that temp variable into the vector. So let's say our first value is 1. So initially the vector is empty, temp holds 1, and then I put the value 1 into the vector, and now the vector has value 1. And it also has a size of 1. It does not have a size of 5. When you were doing this, it had a size of 5 every time you were inputting something. But at this point, whenever you push an element, it increases the size by 1. You see, there are very certain differences. You can use either of these things. It's completely up to you. Of course, if you have to input, it's better you do this, because sometimes this is very handy instead of using this in temp, seen temp thing. Of course, this is if you want to just keep it simple and short, and you know the elements already. Apart from that, let's say this is a very important segment. Let's talk about some important functions that are related to vectors. So, firstly, we create a vector. Now it holds these values, and so you say v dot back. So what is v dot back? Remember, this v is actually the name of the vector. So when you say v dot back, it actually gives you the last element of this vector. As you can see, the last element here is, just give me a second. You see this last element is 0. So this 0, this vector sees, okay, I have all these values. So I use v dot back. That means this last value, and it print. So it prints 0. And it says v dot size. Now again, v dot size is the number of elements in this vector. So it's 1, 2, 3, 4, 5. Remember, indexing starts from 0. So v dot back gives you the element at index 4. But v dot size gives you the size of this vector, that is 5. And so v dot size minus 1. What does this do? So this thing first gives you 5. And this thing is 5 minus 1, that is 4. So v of 4. And you know, indexing begins from 0. So this is the fourth element. It again gives you 0. Now back gives you the last element of the vector. Size gives you the size of the vector. And random access. What does random access mean? Random access means you could just put any index in the vector using the square brackets, as we have done here, and it will give you the element present at that index. Of course, if you were to put 6 here or 5 here even, now v of 5 does not exist because it only holds 5 values and the last index is actually 4. So random access gives you this. Now we will be beginning a very important segment, that is iterators. So iterators in general is very large. It's not necessary to cover everything. Giving you a basic idea of iterators from this perspective, the vector perspective, will actually help you go further, because there are many more data structures like map and unordered map that are impossible to iterate through if you don't use an iterator, because map does not actually have a random access. You can't just say map of a map of this is this. You can actually put some element into that, but if you have to iterate to the entirety of map, you can't use that. So we'll begin iterators. It's very simple. Firstly, we have this vector, the good old vector, and then you say sort. So sort is a function, as we discussed earlier. It also has a lot of different things. For example, sort. Right? So you do go down. Sort. You say vector dot begin and vector. What are these things? These are actually your iterators. So a begin iterator actually is the first element's position. It's not the first element. It is just telling you where is the first element. It's also not a pointer. It's a little different from a pointer, but you can almost say it's a pointer. It tells you where the first element is. It does not say what the first element is. It just tells you where the first element is. So you see here's a 6. So v dot begin will actually give you the location of this 6. It will not say it's a 6 here. It just gives you location. Similarly, you have v dot end. So v dot end is not actually the last. It's a little different. It points to the position just after the last element. It's not the last element. It's not pointing to the last element. It is the position just after the last element. So end is just after your vector ends, this place. However, begin is where it starts. Now you might say, why is it not at the end? It serves a very good purpose when you are trying to find if an element exists or not. That's a different story. We'll discuss it tomorrow. So let's talk about this again. Sort vector dot begin vector dot end. What does it do? So what it does is, it says sort my vector from this position, again this 6, the begin, to this end. This end is not inclusive. So it says sort from this 6 to this last position. So by default, when we talk about sorting, it's the ascending sort or the non-decreasing sort. So it's 0 to 469, you can say here. And when we say vector sort vector dot r begin, now r begin means reverse begin, or you could just say from this position to this position. So what it would naturally do, see, if you even if you were to sort from this to this, it would give you the same thing. But by this we mean sort it in reverse order. So decreasing order will give you 96420, and increasing will give you 0 to 469. So it's this thing. Remember, it's always sort v dot r begin v dot end. You don't put any indices here. You just put iterators here. These are iterators. These are not indices. These are not pointers. These are not elements, these are iterators. V dot begin pointing to the first element, V dot end pointing to after the last element, not the last element. But there's also a slight caveat when you try to access stuff using this. We'll talk about that as well. So again, V dot begin, V dot end sorts in non-decreasing order, which means ascending. V dot r begin, V dot end sorts in non-increasing order, which means descending. Why is it non-increasing? Because you could have two elements that are same. So 2 and 2 is not increasing or decreasing, it's just non-increasing, non-decreasing. So V dot begin and V dot end are iterators. Again, V here means the name of the vector. It's not anything, you won't use V dot begin every time, it's just the name of a vector. If here it was array, you will use array. Let's talk about iterators again. Iterators are to data structures, but a bookmark is to a book. It's not the page you're on, it's not the page that you're looking for, it's actually the position in that book. So an iterator points at something in a data structure but does not explicitly give you its value. Again, V dot begin won't give you 6, it will just give you the location where that 6 is present. You have to manually dereference it to find what is actually inside that location. So dot begin again points to the first element in a data structure, dot end points to the position just after the last element. So you have this V dot begin, V dot end. But how do you get a value from an iterator? You know that there is something present here, but you want to find what is that exact thing. So what you do is you dereference it. If you've used C a little bit, you might know about pointers. You dereference pointers. You also dereference iterators. So you use the asterisk symbol to over an iterator to dereference it. So if you have int first is equals to V dot begin. Again, V dot begin will give you this location of this 6, the first element or the first place in that vector. So if you were to dereference it, it will give you 6. Now, if you were to, let's skip this one for the time. If you were to say last something, you say V dot end. Now, V dot end will give you this thing. And if you were to say minus minus V dot end, which means basically decreasing it, it will give you this thing, 0, this position. And if you were to dereference this position, it will give you 0. But what happens when you actually dereference this last thing and not this? If you dereference this, it again gives you this. Now I have checked many compilers and many online forums. This is an intended behavior because it will otherwise give you some error. So honestly, I myself have no clue why this happened. And trust me, this is not something you will use anywhere. It's just you will use V dot begin and V dot end only for like functions like sort and binary search, etc. You won't use it to do this to dereference it. So that's a certain thing you should know in case somebody asks you. Apart from that, again, there are also important things like max element. So what does max element do? It actually returns you the iterator of the element, the maximum element present in that array. So what we're trying to do here is, let's forget about this dereferencing. So you say max element, V dot begin, V dot end. Again, you specify the range. The range is this and to this. Again, end is the after the last element, not the last element. Begin is however at the first element. So you could also say V dot begin, comma, V dot begin plus 3. So it will give you from the first 3. Okay. This 1, 2, 3, 4. So first 3 indices like 0, 1, 2, 3. So it will give you from here to here. It won't see this 0. So if you were to say min element V dot begin, comma, V dot begin plus 3, which means this plus 1, 2, 3, it will give you the minimum element from these 4 and not this. So technically answer should have been 0 if you were to find the minimum element from the entire array. But since we're only finding from the first 4, it will give you this 2. So here, however, we have used the entire array. We say V dot begin, V dot end, V dot begin, V dot end. So we say max L, which means maximum element. We dereference it, max element. This entire thing, apart from the star or the asterisk, actually gives you an iterator. So this max element will give me the iterator for this thing, this 9. So it gives me an iterator for this 9, and when I dereference it, it gives me the value that is present there. So it gives me this 9. When I use min element, it gives me the iterator for this 0, and when I dereference it, it gives me the 0. If you were to remove these things, you will get an error, which means or you could get a type conversion which means that this thing is actually returning an iterator, but without dereferencing it, you're trying to put it in an int. That would be a problem. Again, iterators are similar to pointers, but not exactly like them. So do not worry. It's not something anybody would be asking you. Iterators are just there to help you to use functions. For example, this is a function again. This is a function. Sort is a function. So iterators just tell you, okay, I have to search from this to this. Now you could have used indices, but iterators serve a very good purpose. The reason you do not use indices is because let's say you have to find if 9 is present, so if it will give you an iterator to 9, but giving an index to 9, you could be using a different sort of indexing. So using just indices would cause a problem. Iterators do not have that problem. What iterators do is they keep a track. So in a data structure such as a map, where you do not have everything in a sorted order or in an order, it's just random order. So iterators serve a very good purpose. When you have a random order, you do not know what index to use. So iterators will give you a very good purpose there. Apart from this, max element again returns an iterator to the max element. Main element returns an iterator to the main element. Now let's do some questions. But before that, before this question, let's again revise how do we use all these things. Let me just go back. So a vector we have discussed what a vector is. It's similar to an array. It's just vectors can resize themselves, and you have a lot of function capabilities in a vector. So built-in functions. A vector has a lot of built-in functions. And apart from that, how do you create vectors? This is how you create a vector. So you put vector, and then you use angular base. You write a data type. You use closing angular base, and you put the name of the vector. This is how you create it. Again, this is not this is just defining a vector. This is not allocating memory to it. Once you have to allocate the memory, you could manually do this. So it allocates 5 blocks. Again, you can also increase the size of those blocks, or you could just say vector in nums braces n. So this allocates n blocks. All of them are filled with 0. And if you say n comma 1, it allocates all the blocks with 1. So this, let's say if n is 5, so it will become 1, 1, 1, 1, 1. And if it's this, it will become 0, 0, 0, 0, and 0, a total of 5. So if n is 5, 5 zeros. If n is 5 again, 5 ones there. But if you have to insert at runtime, you could do a simple thing. You could say scene nums of I. You'd only use this once you have put some memory. You said that vector has a memory of 5 blocks, so you can easily put elements into those blocks. What this is doing, however, this thing here, it's just saying this vector exists. Once you do this, it says the vector exists that has a size of n. And once you say this, it says a vector exists that has a size of n, but each of those n blocks is filled with 1. In this case, however, it's filled with 0. So all these elements are 0, all these elements are 1. And again, you could do this. You could use a temp thing, which means that firstly, it will be empty. Once you put 1 in that, it becomes 1. Once you put 2 in that, it becomes 1 and then 2. And once you put 3 in that, it becomes 1, 2, 3. So it keeps on increasing 1 by 1 until this loop ends. In this case, however, it's already at 5. It's got all those 5 blocks. It's just filled with 0. So once you put elements, it changes first 1, and then there are 4 zeros. Then it becomes 1, 2, there are 3 zeros. Then it becomes 1, 2, 3, there are 2 zeros, and so on. In this case, again, it's just 1, no zeros. 1, 2, no zeros after that. 1, 2, 3. So you see, this is increasing the memory 1 by 1. However, already keeps the memory with it. So important functions again. So we have v dot back. It gives you the last element at that vector. Here it's 0. V dot size. It gives you the size of that vector. Again, size is different from indexing. Last index is always size minus 1. It gives you, now this is random access, v dot size minus 1. It gives you the element at v dot size minus 1 index. So this is 5, this is 1. So it's 5 minus 1, 4, and fourth index is this. So it gives you 0. Back size random access, we've discussed this. Sort, again, remember sort does not use indices. Sort does not use values. It just uses your iterators. Iterators, again, what are iterators? Iterators are pointing to specific places in the vector or any data structure for that matter. In this case, begin points always to the first element, however, end points at the end of the vector. It's not at the last, it's at the end of the vector. How do you dereference an iterator? How do you get value from that? Simply use an asterisk symbol. Max element again uses this, min element uses this, and I'll take your doubts right now before we solve the question. If you have any doubts, type in chat. If you do not have any doubts, give me a thumbs up. So I'll take that as a no. So if you have a doubt, please type. It's completely fine. Can we store string or character in vector int? See, the thing is, Saksham, when you have vectors, so you said, let me just go back. So you say, can we store string or character in a vector of int? So you have vector of int. What does that mean is that this vector actually, it will store ints. So when you try to push a string in this, or when you try to push a character in this, so each character has an associated value with it. It's called an ASCII value. So the ASCII of capital A is 65. So once you try to push this character into this vector of ints, what happens is that this character A first gets converted to a 65, and then it stores this 65. Now this is called implicit conversion. There are also explicit conversions. For example, if you have to change something that has a high priority, you have to change something from a low priority to a high priority, you need to use explicit conversion. Regarding strings, I think it will throw in an error. Apart from that, it could possibly take the first element of the string and then convert it into its ASCII value and then store it there. That's how it works. I hope I've cleared your doubt section. Any other doubts? Yeah, and I'll share these notes. These are on Excel Draw. I'll share it with you, or I can basically convert it into PPT. I'll share it with you. Are we ready to do a question, everyone? Can I have a show of hands? So I guess only Saksham wants to do a question. Nobody else? Okay, Shivani, Saksham, Arv, Himanshi, Amit, Ravitvi. So I think we are pretty much ready, and Divya and everybody else. Okay, so I think we're pretty much ready to do questions. So again, now I urge all of you to have an account on LeetCode if you have not created an account on LeetCode, because LeetCode actually gives you the access to do a lot of questions. So let's start with this. So this is our question for today. Remember, this question is only for you to understand vectors and iterators and everything else. If you want to go through the entire list of our questions, we will be posting that on Codeboard. Codeboard will be up very soon. So it says, this is the question code. It's lead code 1431. So the question is kids with the greatest number of candies. So the question says that there are n kids with candies. You are given an integer array of candies where each candies of I represents the number of candies the ith kid has. So this could be a little confusing to you. Uh, Try to read something again if you have confusion and stop halfway there. Do I understand the partial here? Yes. There are n kids with candies. Do I understand the partial here? You are given an integer array candies where each candy has number. No. So it's starting. So it says you are given an integer array candies. Okay, cool. I know what it means still. Each candies represents the number of candies the ith kid has. So that means this array actually the first kid, or let's say this kid at zero index, will have candies of zero, and the ith kid will have candies of five. So also we are also given an integer extra candies. So this is a number. This is an array or a vector. This is again a number. So return a boolean array result of length n, where result of I is true. If after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. So what it says basically is that in this case you have 2, 3, 5, 1, 3. But these are all the candies the kids have. So you have extra candies of 3. So check that there are a maximum of 5 candies initially. So you have, if you give these 3 candies to the first kid, it becomes 5. So 5 is actually equal to 5, which is the greatest number. So that means this kid also has the greatest amount of candies. So that becomes true for this kid. You see, they will have 2 plus 3, 5 candies, which is the greatest amount of kids. So that is true. Now, for this 3, it will become 3 plus 3, 6, and 6 is actually greater than this 5. So that is also true. For this 5, 5 plus 3 is 8, 8 is greater than itself 5. It's also true. For this 1, it will become 1 plus 3, which is 4. And 4, you see, is not actually greater than the maximum candies, that is 5. So that's a problem. So that becomes false. So 3 here, again 3 plus 3 is 6, and 6 is greater than 5, that is also true. So this is the output array. So how do you go about solving these questions? Firstly, you see, you write all the things that are given to you. I tell you, identify the information provided. So we write that n is the number of kids we have. Candies is the vector that contains how many candies each kid has, and extra candies is how many extra candies you have. So what do? You need to check if giving the extra candies to the ith kid makes the ith kid with most amount of candies. This is what we have to actually do, and then we have to return true or false based on if the answer is yes or no. So this is the indices. These are the indices, and this is the actual array. So it says 2, 3, 5, 1, 3. And so the element at zeroth index, or let's say I is equal to 0, is actually 2. At 1, it's 3. At 2, it's 5. At 3, it's 1. At 4, it's 3. So extra candies is 3. It's given to you. So this is the output that we need to return. So it's true, 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 false, true. The answer we need to return. So how do you go about solving a question? Now this is applied to any question, not just this particular question. It says identify the information provided. Now here, what you have been provided is actually the array of candy values, that is candies, and extra candies. These are the only two things you're given. See, you have been given input as extra candies and candies. Then you say is read the examples. So you go to the first example. You try to make sense of that. It says 2, 3, 5, 1, 3, and you try to evaluate it, and you have an answer. If you understand the answer, that's great. And if you do not understand the answer, there is also usually another example that will solidify the approach to you. After that, you generalize. Once you've done one or two examples, you create another example of yours. You try to generalize what the answer is. So in this case, it's this. So what would be the answer if I have some random arbitrary values? After that, you find edge cases. Now this is where a lot of people struggle. So edge cases is the cases that tend to break your code. Usually, your code might run for 400 out of 410 cases, but those 10 edge cases, those are the cases that are intentionally designed so that your code breaks and so you think again. It's very easy to do those 400, but it's very hard to do those 10 out of 10 out of 410, let's say. And again, slay. Once you've done all this, you just write your code and go by. So in this question, let's apply these things. Firstly, we need to identify. So given an array of candy values and extra candy values, this is identifying what we've been given. After that, in the example, we see that we can only assign extra candies to one child. So this is reading the example. I said read the examples. So why this helps is because somebody might have thought that, okay, the question says, let's assign these 3 to each of these. So 2 plus 3, 3 plus 3, all this, and then check which one is the maximum. But that is not the question. You have to always make sense of the question with respect to the example. If these two things are disconnected, you won't get the answer. You might think this is a different question and this might give you a different approach. So once you are differentiating on this, you do not get the answer. Once these both things are in synchronous, these are in sync, so that's you get the answer. So that means we have to check if assigning this extra candy to each child once exceeds the maximum candy value present in the array. So this is generalizing. Once you've read the example, you generalize. You do not solve the question for just 2, 3, 5, 1, 3, and 3. You solve the question for all the values. So that is generalizing. And here we have vaguely defined what it means to be greater than a particular value. Now, other thing is, somebody might say, okay, there was a case with 5 and 5. So 5 was the maximum value in the array, and 5 is what we get after adding 3 to 2, the first kid, or the kid at 0 index. So is in that case, do we return true or do we return false? That is where edge cases come in. And this is a case, if you do not see this case, this 2 plus 3, 5, you may assume that every time you get the answer, so simply 5, 5, you might put the condition as greater than, and it will become wrong. Even though the answer is true, you have to say 5 is greater than equals to 5. That is when you get the correct answer. So what if the max value in vector is the same? So this is an edge case. So the max value we had is 5, and when we add 3 to 2, it's also 5. So edge cases are something that will break your code, so you have to be very careful. Clearly in example 1, we can see if the max value other than current is same, we return true for that child. In this case, we had 5 here, and we see that 5 is also present. So 5 is actually greater than equals to 5, so we return true. We return true. So now that we've established the procedure, how do we write the code? So firstly, if you need to write the code, you have to always break it down. You have many different steps here. You have step of finding the maximum value. You have step of assigning the value to each of the kids. So how do you go by? So firstly, break it down. So example, break the code down to the smallest units. In this case, you have to find the largest value in the array and can be sorted separately because it won't change. So we need to repeat it again. So once you found the largest value, you do not need to repeat the entire thing again. The largest value remains the same. 5 will always be 5 here. It's just you have to change values for all these individually to check if they exceed this 5. Now, now let's solve this question. I'll open this question and I urge all of you to also open this question side by side so that you can easily solve it. This is the question we're talking about. I hope it is visible to all of you. Can I have a show of hands or thumbs if it is visible to you guys? Okay, cool. So again, the question. This is the question, and we're supposed to solve it using this information and this. Do not worry about the constraints just yet. I will be having a session in which we will solve a lot harder questions and tell you how to actually read the constraint and what does that mean for you. But as of right now, this is an easy question. So let's begin. So firstly, let's start by defining this size of this candies. We do not know which size this have. So let's say that int n is equals to candies size. Now we know the size of this array, this vector. We need to find the maximum value. So we have to exceed this 5. In this case, we have to exceed this 4. So what we do is we say int max candies is again what thing can we use to find the maximum value here. If you remember very carefully, we just use this max element. So this function using these iterators will give you the maximum element. You could do that, or you could do the old way of, you could do the old way of int max candies is equals to something like -1, and then you do is for int I is equals to 0, I is less than n, I plus plus, and then you could say max candies is equals to, let's say, you say if candies of I is greater than max candies, then you say max candies is equals to candies of I. You could do this, or you could reduce this entire thing by just one single statement, and that is int max candies is equals to max element, and the name of our vector here is candies. So you can say simply candies dot begin, candies dot end, and you see this code of 5 lines for finding the maximum candy in this has just been reduced into a single line. This is how vectors. This is something you have to use for an array. This is something you can still use for a vector. You can use this for vector as well, but you can't use this with an array. So this is where vectors and still come. You have reduced this entire thing into this simple one line which finds the maximum. It is very easy to find this, so why not just use this function as well? So once you're done with this, now we have to return a vector of booleans. So you know how to create a vector, and then you write the type you want to create, bool, and then let's say they have asked us to return something like uh, it says return a boolean array result. You could name it anything, but let's just name it result. So we also know the size of this is going to be same as the size of candies, but we can also prevent that and just simply use it simple like this. We say for int I is equal to 0, I is less than 10, I plus plus. We say that if candies I plus extra candies is return equals to max candies, simply say that the current answer is true, and otherwise what we are going to do is answer dot push back. Yes. I hope I have not made any spelling mistakes here. Yep, I have. It seems. Oh, I wrote answer. It's supposed to be result. Yep, it works. So the thing is, it works for these three cases. You've been given three cases. So let's say we did not pay any attention to the fact that we had 2 plus 3 equals to 5 and 5 is also present. We just wrote here greater than. Watch what happens when we just use greater than. We run this code and you get a wrong answer. The reason you get a wrong answer is because we did not indeed solve this. We just believe that, okay, whatever the candies we have to add it to max candies and we have to check if it exceeds this max candies. The problem is if you do not read with conjunction to this, this is where you get the description. This is where you get the idea. They have solved it like this. So 2 plus 3 is actually equals to 5, and that case is actually true. So that is why you have to read the cases. So you have to put here equals to and you have to solve it. You see, it's accepted. Let's submit this. And yes, it works. So one more thing important on this liquid is that never look at this thing. It's a very vague stat. It says 0 ms. It says 12.44 megabytes beats 59%. Do not run after the fact that you did not beat 60% people or you beat only 10%. I'll show you the problem with this thing is if you see my submission that was about 2 hours ago, it uses it used 12.34 megabytes of memory and it beat 92% people. But this particular solution only beat 59% people, even though it used, let's say, 200 kilobytes less. So do not run after that. Rather, what you should be looking at is once you're done with the question, you should look at what is the time complexity. For example, here what we've done is a time complexity of n, where n is the input size of the candies vector. So that is something you need to look at. That is something you need to optimize. Can you do it any further? Any further, this would be log n or square root of n, or maybe even log base 10n. But as of now, I'm pretty happy with my solution. So once you're done with this question, let's say you solve it on your own. What is the next step you should be doing? You should be going to editorial if it's available. Here it's available. You should be reading this editorial. So these people actually did it. You see, this lead code editorial is done using that thing. 4 in candies, max candies equals to this. But what we use instead here, let me just close this, is this vectors function, that is max candies equals to this. So this is where it helps you. Once you're into competitive programming, you will realize how important all these functions are. It just gives you a very easy access to this entire code. And in competitive programming, let me tell you, it really matters in seconds how early you solve a question. For something like this, an easy question can set you back about a few hundred ranks. So for this, again, they sorted like this. It's very easy. You see the editorial. Once you're done with that, you see the editorial. And let's say you do not understand the editorial or you're not happy with the solution. What you do is you go to solutions. There are a lot of solutions here. There are people with, there will be people who will be writing stuff like beats 100%. You see this. Do not believe these people. It's just given to satisfy your ego. It just says beats 100%. Now, what see again, they use the same thing. What you should really be running after is the time complexity. It says O of n, and something else might say O of n square. So again, n is still better. So that is something you should be behind, and that is something you should be trying to optimize rather than your beats 100% or beats 50%. Do not worry about that. In case it could be possible that your code beats very less, let's say beats 2% and has 50 milliseconds of runtime, or it has 15 megabytes of memory. That's somewhere an indicator that your code is okay, it works. It's just inside the bounds, but it's not very good. So if you have to make a code very good, you could still look at something. There could be a redundancy in your code. For example, you could be finding this max candies every time. But this entire operation takes O of n. It has to go through the entire vector and find. So you also do this n times. So n times n is n squared. So you could be doing this max candies thing every time. For example, let me just try this and let me just put it here. So if I were to do this, I think, yeah, I'm inside the box. So if I were to do this, and if I were to submit the solution, let me see if it works first. It should by all means work. So if I were to do this, and if I were to submit, so it still beats a lot of people. Still does this, but the suddenly the time complexity of this code changes. This code right now becomes n squared. Why is that? Because each time you're solving, each time you're going through the array, we're also trying to find the maximum element. So this in itself takes of n time complexity, and this entire loop takes of n itself. So this code suddenly becomes n squared. Now for something like this question, which only has like 100 elements in the array, it's not a lot, because 100 times 100 n squared is 10,000, and that's very normal compared to having 10 raised to the power 5 operations or 10 raised to the power 9 operations. So in this case, this does not matter. Also, it's a very easy question. There are questions where you will have time limit exceeded because your code is not very optimized. That's where you have to look into the time complexity. There will be cases where you will have memory limit exceeded, where your code's memory is a lot, so you have to cut back on the variables or data types you're using. Apart from that, there are many other questions I would love to discuss with you. But I think today's session has been a success so far about this question. So I will be sharing this PDF with you. And the purpose of this session was not to solve a lot of problems. It's just about STL. Why use vectors? So vector in general. This was a vector class. So also how to define a vector. What is an iterator? Because remember, iterators you will have a lot of problems. We just begin iterators from start. Rather try to solve it with the problem. So try to use this thing wherever you can, so you will have a grasp on iterators. Also, try to use this sort function. So whenever you're trying to sort the array, of course, if your teacher asks you to implement a sorting, do that. Do not do this. You will lose marks on that. Uh, and I think that's about it. So any doubts, you're welcome. I will be turning on your voice chat soon. But firstly, please write it down. If you have understood the entire session and have no doubts, can I have a show of hands? Everybody else is either not present or they have doubts. So if you have doubts, just write here. It's completely fine. Do not think that my doubt is very silly or it is very trivial. I'm here to solve all your doubts. And today's question, ask me anything about vectors that you think you're having trouble with. You are now allowed to use your microphones. So any doubt, please tell me. I'll take as no doubts. So any suggestions or any feedback anybody would like to give, you're free to write it in chat. I think then that's it, and everybody's free
Anand,
to leave. If you have any doubt, let me know.
actually, they have doubts. They have raised their hands.
Okay, yeah, cool, cool. Speak. You can turn on your microphones. I have updated the setting. If you have a doubt, you may speak. Well, now they've lowered their hands, so never mind. So, no, regardless, I think that's it. You have any feedback or anything, there are discussion groups in coding community. You can just put your questions there, and I will be sharing this PDF or this link at least very soon. And apart from that, again, we will be having the YouTube streams as well. I'll start a GitHub repo for this, and lead code daily will be discussed after a few sessions. So once we're done with the introductory sessions, we'll give you questions every day. We'll be using code, and that's it. I think, yeah, that's it. So thank you so much, and I